Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform, where you get the opportunity to learn from India's best and top educators who will prepare you for the competitive examinations, whatever you aspires, GATE, ESE, and every competitive examinations. So I welcome you all. So I welcome you all. This is a brief introduction about myself. My name is Vidyapati Kumar, and I have a 4+ year of teaching as well as R&D experience. And I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice. I am the author and co-author of various several research papers. And if you have a keen interest about the research works, you can Google about me and study about my research works, whatever I have done. Okay, so in this session, what we are going to deal. Earlier, we have seen what are the shear angles, what is the metal cutting, how the metal cuttings are done, what are the types of angles, tool signatures, tool designations, shear plane is there, how the shearing actions actually makes the chips, and what are the different types of chips, what would be the analysis of that chips, what would be the advantages and disadvantages, and how the chips are forming. So these things that we have actually seen in the great details. And in this session, what we are going to do, we are going to see the forces involved in that metal cutting parts. So this is what is the session is for, analysis of metal cutting. This is a part one. You can download the Unacademy learning app, which has a great importance. You can practice a lot of tests, quizzes, and as well as what is the benefit of that, there is the daily live classes are there. At the Unacademy learning app, you can have the daily live classes that is a free of cost also, even if you are not the plus membership. And there is a structured courses, right? So in YouTube there might be, the thing is that after lecture 1 you would get to have a lecture 3 or lecture 4, something like that. So there is no chronological order is there, but in app the structured courses are there. So and free test and quizzes are there, so you are very much most welcome to this app to practice and increase your chances of GATE preparations as well as GATE rankings. Next is their plus subscription. If you are interested for the plus subscription, the benefits of plus subscription is daily live classes is there. Every day you will have a daily live classes from the top educators, complete coverage of every subjects, theory of machines, fluid mechanics, strength of material. Every subject will be completed in great details, solving of a lot of questions, previous years, tests, quizzes, and unlimited access is there. So these are the top educators, and the Unacademy has a lot of courses for mechanical engineering, instrumentations, production, civil, ECE, electrical, and there are a lot of things. So if anybody is interested for the plus subscription, this is the amount for a 1 month, and for a 3 months, for a 6 month, and for a 12 month. So if anybody is interested to purchase the 12 month, it would cost around 25,000. The subscription for plus would cost around 25,000, but if you would use my code SIRVK, then you would get the additional 10% off, as well as I will give you my personal mentorship. Okay, so the discounted amount would be 22,500, and believe me, this will be going to be worth it. That would be around 60 rupees per day. So I think that is worth it to invest 60 rupees for your preparation of GATE and ESE. Similarly, for the 24 months, you will be charged at 30,000, but if you would use my code SIRVK, then again you would get the discounted amount. The discounted amount would be 27,000 and you will get a 10% off in there. And if you would take the day-to-day basis, it would be around 37 rupees per day. So if anybody can afford, they should purchase. And if you are purchasing, please remember to use my code. My code is SIRVK. And so this is all about the Unacademy. And let's talk about our session. But before starting the session, let me check the comment box. Hello Indrajit. Good evening Ajay ji. Okay. See, this is the workpiece. Fine. So this is a tool, right? This is a tool, and this is a chip. Okay, this is a chip, and this is a workpiece. I hope you all know these things, right? Because I have discussed these things in very great details. Now, what is this? What is this? Sir, this is shear plane. This is shear plane. This is shear plane. And sir, this is shear plane, and in this direction the chip is moving. Fine. And you are giving the tool a cutting speed, right? You are giving a tool a cutting speed. Fine. So this is a cutting speed, and I denote the cutting speed with V. Clear? Okay, how many of you have joined? Yes, good evening Nishant, good evening Asis, good evening Mukta, good evening to everyone. So I hope this thing is basic thing, this thing is clear. So this is your shear plane. This is your shear plane. This entire is your shear plane. In this direction the chip is moving, and what you are giving the tool, you are giving a cutting velocity V, and this cutting velocity V is in this direction. Now see this chip is a, when we are calculating the force analysis, there is a assumption. What is the assumption? Sir, chip जो है ना हमारा, वो चिप को मैं एक अलग आइडेंटिटी बॉडी ही मान लेता हूं, एक अलग बॉडी मान लेता हूं. ठीक है सर. चिप जो है वो वर्कपीस से निकलना चाहेगा क्योंकि टूटा रहा है. तो क्या होता है सर कि वर्कपीस एक रिएक्शन लगाता है सर चिप को कि भैया चिप आप मुझे छोड़ के मत जाओ. Again I am telling you, when you are giving a cutting velocity V and the tool is moving, then chip will get separated from the workpiece, but workpiece will give a reaction force to the chip to avoid the breaking of the chip. Clear? So that reaction is this. Clear? So this is a reaction. Actually, this is the reaction. This is the reaction that is denoted by R. Fine. This is a reaction that is denoted by R. Okay. So, and what will happen? Similarly, tool will try to move that chip from the workpiece. टूल क्या करेगा सर? टूल जो है चिप को हटाने की कोशिश करेगा. टूल जो है वो चिप को हटाने की कोशिश करेगा. तो अजय जी, आई विल डील दीज थिंग्स. मैं बाद में आपको बताऊंगा. किसी किसी पीएसयू में प्रॉब्लम होता है, बट मैक्सिमम में प्रॉब्लम नहीं होता. ओके, सो सी, तो क्या होता है ना सर, दिस इज योर आर. Fine, this is your R. So this reaction is actually चिप को रोकने की कोशिश कर रहा है, एंड दिस रिएक्शन कौन लगा रहा है सर? दिस रिएक्शन इज गिवन बाय वर्क पीस. फाइन, work piece is giving a reaction that is R. Now see, tool will also give a reaction. Tool will also try to move that chip from the workpiece, correct? So for that, this is a line of action of the R, right? This is the line of action of R, and in the same line of action R, again the another resultant force, that is reaction force, that is acting, and that is denoted by R dash. Clear? So there is a two resultant force and reaction, that is R and R dash. R dash is given by tool and R is given by workpiece. Clear? So let me tell you one thing. As chip is moving with constant velocity, V net resultant force on the chip must be 0. Since we are assuming that chip is moving with constant velocity, sir, if a chip is moving with constant velocity, then velocity is equal to constant. Then sir, dv by dt is equal to acceleration, and acceleration would be 0. Clear sir? This is clear. So in this case sir, net resultant will be net resultant force on the chip will be 0. Clear? So this is the thing, on the chip must be 0. So for this case R is going to be equal to R dash. R is going to be equal to R dash. This is equal and opposite. Sir, please tell me if you have any problem. Sir, please tell me up to till now, whatever the concept I have given you, till now, do you have any problem? Do you have any problem? Please tell me fast, because this lecture is going to be the foundational lecture of everything. This is going to set the foundation of your GATE and ESE. This is how the machining is done. ये बहुत important है चीज सर, इस फंडा को आपको समझना बहुत important है. Please tell me, this is understandable or not? आप जो समझ सके हैं कि नहीं? Have you understood this or not? Please tell me. Please tell me, sir. नहीं अजय जी, for teaching job it doesn't matter. Okay, so I assume this thing is clear to you. So if this is clear to you, sir, let me move to the next thing. Okay, Madhavnath Baburam has told once again. Okay, please understand this. Please understand this. Madhavnath ji, please see here. This is my workpiece. This is my workpiece. So this is my workpiece, and what is exactly happening, sir? This chip is moving apart from the workpiece. This chip is moving apart from the workpiece, but workpiece says that Please, chip, do not go. I do not want to let you go. So for that reason, chip is holding that chip. And for that sake, chip is workpiece is providing a reaction force to the chip, that is R. That is R. Clear? And and next is tool. Tool tries to cut the chip. Tool tries to cut the chip and move it away. But so for that reason, tool is again giving the reaction, that is R dash. And line of action of R and R dash, line of action of R and R dash both are same. And one most important thing here, we have assumed that chip is a separate body. Clear? Chip is a separate body and chip is moving with a constant velocity v. So sir, what is the meaning of constant velocity v, sir? Sir, if constant v is constant, then dv by dt, that is differentiation of velocity, that is acceleration, and acceleration is going to be 0. So net resultant force on the chip must be 0, sir. So if net resultant on the force is going to be 0, that simply means that R is going to be equal to R dash. That is, sir, it is equal and direction is opposite, sir. So equal and opposite. So I hope this is clear. These are part and parcel, Vishal. These are part and parcel. Okay. So now I am going to discuss the assumption of MCD, right? So MCD is actually written as merchant force circle diagram. Okay, sir. So what are the assumption of MCD, sir? Yes, Ajay. It simply means that net forces in this arrangement is 0. Yes, net forces on the chip is 0 and chip is in equilibrium. Of course, chip is in equilibrium, है ना? चलिए, good. So what is the assumption of merchant force circle diagram? So let me first tell you, merchant was a scientist, and what he did, sir, he actually tried to find all the forces, whatever the forces that are involved during the machining. And what he done, sir, he combined all the forces in a circle. He combined all the forces in a circle and given a correlation between them. Mind it, this is what the merchant sir has done. Merchant sir has done this analysis for the orthogonal machining. For the orthogonal machining. Okay, for the orthogonal machining. So what is the assumption, sir? No contact of rake face on the machined surface. Clear, sir? Width of chip remain constant. So there is a constant width of the chip would be producing. Next is, sir, uniform cutting velocity. So I have already told you, sir, if cutting velocity would be 0, then dv by dt is going to be your acceleration, and that is equal to 0. So if velocity is your constant, then dv by dt is going to be 0. Merchant force circle diagram. Vishal, please study. I am telling, मैं आपको पढ़ा रहा हूँ, प्लीज आप यहाँ पढ़ लें. These things are none of useless. These things are useless. Please study whatever I am giving you, and hopefully if you will study, then you will be sitting in a good IITs or even in ISC. Please study these things. Okay. Next is due to shear. Sir, what happens due to shear? Please try to understand. Again, this is your workpiece. Sir, this is your workpiece. Now again, this is your shear plane. This is your shear plane. This is your shear plane. And you are giving a cutting velocity V. and the chip is moving in this direction. Correct? Chip is moving in this direction. So I have again told you, this is your primary shear zone. Clear? This is your primary shear zone. This is your primary shear. So this is your primary shear zone. So in this primary shear zone, what is happening, sir? There is a shear plane, and in that shear plane and shear zone, a shear force will produce, sir. Okay, sir? A shear force will produce. So kindly see, this is a shear force. This is a shear force. This is the shear force. Clear? Shear force का direction क्या होगा सर? इस direction में. This is the shear force. And see, shear force के perpendicular normal में क्या होगा sir? There would be a normal force. There would be a normal force. So what is Fs, sir? Fs is the shear force which acts along the shear plane. Shear force which acts along the shear plane. And this is the resistance of shear of material in forming chip. Clear, sir? Now, next is your reaction force, that is Fn. Clear? So this is your normal force Fn, which is acting on the shear plane. So Fn is the force acting normal to the shear plane, and this is the backing up. This is the backing up force on the chip provided by the workpiece. Clear? So I hope this is clear to you. Till now this is clear to you. So at the shear plane, there is two kind of forces there. And what are the forces, sir? Forces is your Fs and Fn. Clear, sir? And there is a resultant of Fs and Fn, that is R. There is a resultant of Fs and Fn, that is R. Clear? What we have seen here, sir? पहले मैंने देखा था ना, sir? What is that? That is, sir, R is equal to R dash, and this is the R. So this is the resultant R, जो कि sir Fs and Fn के terms में break कर गया, sir. So the horizontal and vertical components are Fs and Fn of R. So this is clear to you, sir? Yes, Ajay, these things are there. Yes. Now see, what we are doing, sir, we are actually trying to integrate the Fs and Fn and R in a circle. कैसे करते हैं, sir? जरा देखिए. Please see it, sir. Now see, this is your tool. This is your tool. Fine, this is your tool, and this is your rake surface. This is your rake surface. Clear? Now this is your shear plane. This is your shear plane, and this is your reference line, reference plane. This is your reference plane. Clear? And this angle is alpha. This angle is alpha, rake angle. I have told these things in earlier classes, sir. This angle is alpha. And see, this is what we have done. We have Fs is there, sir. So this is the Fs. This is Fs force. Clear? And this is your Fn. This is Fn. And this is your R. Clear? So यहां पर आपको शुभम मेटल कटिंग में आपको अप्रॉक्स 6 क्लासेस वुड बी देयर. 6 क्लासेस में मैं आपका पूरा कंप्लीट कर दूंगा मेटल कटिंग. ये मतलब इसको कंसिडर कर ले 6 क्लासेस, दैट इज 5 क्लासेस. नेक्स्ट मोर 5 क्लासेस वुड बी एनफ टू कंप्लीट द मेटल कटिंग. और प्लीज आप पढ़ें, मेटल कटिंग में बहुत ही डिटेल्स में पढ़ा रहा हूं, और आप मेरे अर्लियर लेक्चर्स को भी देख लें. दैट वुड बी फ्रूटफुल एंड बेनिफिशियल फॉर यू. सो This is your shear plane, this is a reference plane, this is tool, and this is rake surface. So what is there, sir? This is fs, so here is fs, and fn, here is fn, or ye kya hai, sir? This is r, so this is also r. So this, in this fashion, what I have done, I have integrated the shear forces, whatever the forces, that is fn and fs, in the circle. Fine. Next thing is what, sir? Now you have to see next thing. What is this, sir? Next you have to see the, please understand this again, I am telling you the new concept. See, here only you see, please. See, when you are machining, see, this is your shear plane, this is your shear plane, right? This is your shear plane. So what will happen when the tool is moving with the cutting velocity v, and this chip is moved out, then you will left with this type of workpiece, right? This type of workpiece. And here this is called as your, this part, this part is your shear plane, this part is your shear plane, because this is the plane through which the shearing of chip took place. Okay, so this is your shear plane, this is your shear plane. So let us assume this as A, this as B. Now what is this, sir? This is T, this is T, and this T is your uncut chip thickness, uncut chip thickness. Let us assume this as B. So B is your width of workpiece. Clear? Now this is your T, that is uncut chip thickness, and you know I have explained you these things in earlier classes. This angle is known as shear angle. Okay, so this is your shear angle, phi is your shear angle. Clear? Now can anybody tell me, that AB का लेंथ क्या होगा, सर? What would be the length of AB in terms of T and phi? Please tell me the relation of AB in terms of T and phi. Please tell me. Please tell me the relation of AB and AB in terms of T and phi. Please tell me. Please tell me in comment box, please. So much time. T by sine phi. Great. Good. Good, Ajay. I want to make this session interactive. If you are not participating, whatever I am asking, then maja nahi aayega, sir. Please, please. Okay. So AB is what? So AB is length of shear plane. Clear? So length of shear plane is actually T by sine. Yes, Indrajit? T by sine phi. So this is your length of shear plane. Now please tell me, this is my length of shear plane. So what would be area? What would be the area of shear plane? That is AS. That would be AB into width. Width of workpiece. That would be area of shear plane would be AB is T by sine phi, and width is given as B. So width would be B. So this is your area of shear plane. This is your area of shear plane. Clear? Now, 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 let us assume two things. TS. What is TS, sir? So TS is shear stress on the shear plane. Next is normal. What is this, sir? This is the normal stress on the shear plane. क्या था सर? इस डायरेक्शन में हमारा fs लग रहा था सर. So in this direction there is a shear stress produced, and this is the Fn, that is normal force on the shear plane. So in this direction there is a normal stress that will be produced. So having understood these things, what would be my Fs? What would be my Fs? Fs is what? Shear force. What would be shear force? Shear stress into shear area. Clear? So Fs would be shear stress is tau s, shear area is T by sine phi into B. So T by sine phi into B. Clear? So you must remember this formula. You must remember this formula. What is the value of shear force? That is Ts into T by sine phi into B. This is important. This is important. Next, what would be your Fn? What would be your Fn? Similarly, Fn would be sigma n into shear area, because both are acting on the shear plane. Shear plane पे act कर रहा है, right? So Fn would be sigma n into shear area. What is shear area, sir? T by sine phi into B. T by sine phi into. So this is the relation you have to remember, and this is also important. These two relation you have to remember for the shear action. जब shear होता है सर, तो shear force की वैल्यू shear stress के टर्म्स में क्या होती है सर? बहुत सारे एग्जाम्स में क्या होता है ना सर, गेट में निकालने के लिए बोल देता है आपको shear stress निकालिए. ठीक है? इन एग्जाम it is asked to find the shear stress, it is asked to find the normal stress. So for that reason you have to remember these two formulas. So up to till now, if you have any doubt, please ask me, otherwise I am going to proceed. If you have any doubt, then please ask me, otherwise I am going to proceed. यहां तक कोई दिक्कत है? क्योंकि ये दो फॉर्मूला बहुत इंपॉर्टेंट है. पहला क्या? शेयर फोर्स का फॉर्मूला, और दूसरा क्या है? नॉर्मल. ठीक है, नॉर्मल. ये दो फॉर्मूला काफी इंपॉर्टेंट है. इसको समझे, दिस इज योर shear plane, राइट, एंड दिस shear plane का यहाँ पर मैंने shear area निकाला है, ठीक है। This is your width, this is your width, and this is T, that is uncut chip thickness. So everything is same. Yes, yes, Ajay, this is primary, this is primary. Fine. So I have received the good comments that everything is clear, so I'm just moving. See, now, till now what we have seen, sir, till now you have shown me what would be the effect due to shear. What would be the effect due to shear? And what we have seen, sir, due to shear this thing will happen, due to shear this thing will happen. Now what will happen due to friction? Please see, same, there is the tool, this is the tool, and this is your shear plane, this is your shear plane, correct? So what will happen, this is your shear plane, this is your shear plane. Now see, similarly, there will be a force acting in this direction, there will be a force acting in this direction, and this is known as frictional force, frictional force denoted by F, frictional force denoted by F. And at the same way, there would be a normal force that would be acting here, and that normal force is this, right? So it is denoted by N, it is denoted by N. And here a resultant force, that is reaction, that is R, would be lying here. So let's see, this is R dash. At the starting of the session I have told you R and R dash, what are the R and R dash. So here R dash, this is F and this is N, okay? So this is F and this is N. Now when we try to, you know, integrate forces, that is F and N and R dash here, so this is my R dash, this is my F, and this is N. Fine, this is your tool, you all know this is your tool, this is your reference plane, this is your reference plane, this angle is alpha, this is your shear plane, this is your shear plane. Clear? So I hope this is clear to you. And the angle made by this is beta. I'm going to discuss these things, right? This angle is beta. This beta is actually known as friction angle, friction angle. So I hope due to friction, what are the forces that are acting on the chip, that is clear to you, and how we are actually, you know, integrating those forces that are acting on chip in this circle, in this circle. This is clear now. So FF is your frictional resistance of the tool acting against the motion of the chip as it moves upward along the rake face of the tool. And what is FN? Answer, normal to the chip force provided by the tool. So I hope these things are clear. Next, orthogonal component. Sir, actually what you are doing, sir, suppose when you are machining, you are giving the forces, orthogonal forces. At the earlier classes I have told you there is a difference between the orthogonal and oblique. Orthogonal and oblique machining. There is a difference between orthogonal and oblique machining. So in orthogonal, what is happening, sir? There is two component of force that is going to act, and that two component of force is known as FC and FT. And these two orthogonal component is horizontal and vertical. And most importantly, sir, this FC and FT are measured with the help of a device that is known as dynamometer. Dynamometer, sir, एक device होता है, sir. If you are actually in a BTech if you are actually in a BTech college, then you can go to the workshop after this corona is ended. Then you can visit your workshop and tell the supervisor that, sir, I want to see a dynamometer, how a dynamometer looks like. Please see, I want to see that. And with the help of that dynamometer, the orthogonal component, that is FC and FT, that is cutting force and the thrust force, are measured. So this is your workpiece and this arrangement is there. This is clear to you. So what will happen, sir? It is in this direction the FC is acting. This is your cutting force. Clear? Next is, sir, in this direction the FT will act, thrust force. So in this direction the thrust force is acting. And the resultant of these, that is, again, suppose R triple dash, or we have R and R dash. So suppose this is R double dash. So this is the resultant of two forces. And again, if I want these forces in circle, then how it looks like? It will looks like this, sir. This is your FC. This is your FT. This is your R double dash. This is your shear plane. This is your reference plane. This is your tool. And this angle is alpha. Clear? So this is how the things are there. Clear? So now, यहां तक क्या किन्हीं को कोई प्रॉब्लम है? Because I have completed three things what I have completed. I have completed the shear के कारण कितना फोर्सेस लगता है सर, और क्या लगता है सर हमको shear के कारण FS and FN लगता है, ठीक है। और हमने और क्या पढ़ा सर? हमने पढ़ा फ्रिक्शन के कारण क्या लगता है सर? फ्रिक्शन के कारण F and N लगता है सर। एंड ऑर्थोगोनल कंपोनेंट, और ऑर्थोगोनल कंपोनेंट में क्या लगता है सर? FC एंड FT लगता है। तो तीन चीज हमने पढ़ लिया। यहां तक क्या कोई प्रॉब्लम है आपको? प्लीज टेल मी। वी हैव स्टडीड नाउ 6 फोर्सेस। व्हाट इज सर? FS, FN, FN, FC एंड FT। इतने चीजों के बारे में हमने जाना है अभी तक। If you have any doubt, please tell me. Otherwise, I am going to proceed. Okay, clear. Now, when we, और एक चीज आप समझ लें कि आपको क्या मिला है सर? आपको मिला क्या सर? आपको R मिला, आपको R डैश मिला, और आपको R डबल डैश मिला, right? This is the resultant force. And see, when you are machining, these are holded in a chuck, or they are fixed by any fixtures are there, right? Through any means they are fixed, so there is no movement there, right? तो क्या होगा सर? तीनों जो रिएक्शंस, जो रिजल्टेंट R बन रहा है, वो all things would be equal, so that there would be no vibrations and chatter would be there. ठीक है सर? तो जब ये तीनों जब इक्वल होगा, और तीनों को जब मैं एक ही सर्कल में बनाऊंगा, इन द वन सर्कल, व्हेन आई विल ट्राई टू रैप अप ऑल द फोर्सेस, दैट इज FS, FN, FN, FC, FT, then how the circle will looks like? Please see it. So this is your circle, this is your tool. Clear? So this is your tool, this is your tool, and this is your reference plane, this is your reference plane. This is your shear plane, and in this direction there would be a force that is acting, and this is your FS. Clear? This is your FS. This is your Fs. Clear? Now, again there is another force, that is N. That is Fn. Clear? Normal force is there. And this is your R. So this is your R. Next, this is your F, frictional force. Next, this is your N, normal force, and this is making the angle beta, friction angle. What about this angle, sir? This angle is alpha. This angle is alpha. So they are making the resultant, that is R dash is also equal. Next, this is your cutting force. This is your cutting force. So this is your cutting force, Fc. Clear? Next is your Ft, thrust force. Clear? So this is how the things looks like in a one circle. Let us see some comments. Till now ये आपको समझ में आ गया कि कैसे हम तीनों फोर्सेस को कैसे हम एक सर्कल में इंटीग्रेट कर रहे हैं, दैट इज Fs को, Fn को, Fc को, Ft को, F को और N को कैसे हम इस पे एक सर्कल पे हम कर रहे हैं. Which diagram you are asking, Subham? Orthogonal component. Okay. I will explain you. See, Ajay, how the system will be in equilibrium when you are machining. Then you are holding that workpiece in a chuck or in any other fixture, right? So in that way, you are actually restricting the workpiece to not move, right? You are restricting the workpiece to not move from one place to another, right? So this is how you are actually making the things into equilibrium. Clear? In terms of orthogonal component, right? Please remember. Yes, Mrityunjay, I am going to complete. You can watch my earlier lectures what I have given for the metal cuttings. मैं बहुत डिटेल्स में पढ़ा रहा हूँ मेटल कटिंग. इतना डिटेल्स में अगर आप पढ़ लेते हैं तो आपका बहुत क्लियर कॉन्सेप्ट हो जाएगा. ठीक है, चलिए. शुभम जी ने पूछा था क्वेश्चन, चलिए यहाँ देखते हैं. शुभम जी का एक डाउट ले लेते हैं. शुभम, प्लीज अंडरस्टैंड दिस. What will happen? See, this is a workpiece, and in this workpiece, this is the force, right? In this workpiece, a horizontal force will act, right? This tool is actually moving, right? And this tool is giving a cutting force. This tool is moving and giving a cutting force to this workpiece. Clear? So due to this, a cutting force will produce here, and a downward force will produce that will actually push, right? So this force is known as thrust force. I have explained this thrust force when I was talking about side rake angle, I think in second lecture. So please go and refer those things. So this Fc and Ft will produce in orthogonal component as orthogonal machining. I have also explained what is the meaning of orthogonal oblique. Again, I am just writing a simple point that in orthogonal only and only two forces will act, and this is known as 2D cutting. Clear? And oblique is what? Three forces will act, that is known as 3D cutting. Clear? And the resultant of this Fc and Ft is actually R double dash, right? And this R dash and this R double dash, all things are equal. So you can see this in merchant circle diagram, what I have drawn, Fc, Ft, R double dash. So I hope this is clear to you. I hope, Subham, this is clear to you. Orthogonal components. Next, moving to this point. So what are the relation that we can find from here? व्हाट आर द रिलेशन। अब जरा ध्यान से सुने और ध्यान से देखें, क्योंकि ये जो है अब जो मैं बताने जा रहा हूं बहुत इंपॉर्टेंट है, ठीक है। नाउ फर्स्ट रिलेशन, व्हाट इज फर्स्ट रिलेशन, व्हाट इज एफ, व्हाट इज एफ, this is your f, let me write only r so that there is no confusion, right? So this is your f, right? This is your alpha, this is your alpha, so this angle will be alpha, clear? This is your beta, this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. Now you will tell me, sir, how you can say the 90 degree? Sir, there is a property of a circle. If you could remember, there is a property of a circle that any chord, right? If I have drawn this chord and again I have drawn this chord again and I have joined these two things, these two chords. Okay, so this is 90 degree. Again, if I have drawn something like that, taking the diameter as same, then again this will be 90 degree. So this is a property of a circle. So due to this property, we are getting the 90 degree here, 90 degree, 90 degree, 90 degree. Clear? Now please see, this is your alpha, this is alpha angle, this angle is alpha. So this angle will be alpha. Now this angle is beta. So, and see, this is your shear force, so this angle is phi, clear? This angle is 90, this angle is beta. Can you tell me what would be this angle? What would be this angle? Please tell me what would be this angle. I'm asking from you, please tell me what would be this angle. Please reply to me. Don't be a ghost, right? You are studying, don't be a ghost, please reply to me, right? If you would reply to me, it really motivates me that okay, someone is studying, right? Please reply to me. Please tell me what would be that angle. See, very easy is there, try to solve it. This is your beta, this is your 90 degree, and what would be this angle? This angle would be 90 minus beta, clear? And this is alpha, so what would be this angle? Please tell me. Beta minus 5. Okay, Indrajit is telling me beta minus 5. Anybody else? Please tell me, this is basic 10th 12th ka questions hai. Please tell me, very easy, even a 8th class student can tell it, but you are not telling me. What would be this angle? This angle is 90 degree, this angle is 90 degree, clear? This angle is 90 degree. So if this angle is 90 degree, then this angle will be beta minus 1. Clear? This angle will be beta minus alpha. Now please, I am giving you 1 minute. 1 minute time I am giving you. Tell me if you have any problem in angles, designations, how I have given the designation of forces, angles, anything. Please tell me, because I just want to make everything clear, crystal clear, because there is a lot of confusion in this topic is there. So tell me, I'm giving you 1 minute. Please tell me any confusion in angles, anything. Yes, Mukta, you are right. Beta minus alpha is there. Okay, Ajay is telling no. Clear. So I am assuming that there is no problem. Now see, the first relation, what we can write, this is my F. This is my F, that is frictional force. So what I can write as F is equal to R sine beta. R sine beta. Clear? Next relation what I can write is N. What is N? This is N. N in terms of R, right? So what we can write as N is equal to R cos beta. Doubt अगर होता है तो बोलिएगा. Third relation what I can write is FC. For FC, C. This is your cutting force. This is your cutting force, and this cutting force is making the angle beta minus alpha with this R. Clear? So when I will write the FC in terms of R, then angle would be beta minus alpha. So this is R cos beta minus alpha. Next relation is FT. FT के केस में क्या सर, सेम सर, बीटा माइनस अल्फा है सर. ये क्या हो गया सर, वर्टिकल कंपोनेंट. ठीक है सर, ये वर्टिकल कंपोनेंट हो गया. दैट वुड बी आर साइन बीटा माइनस अल्फा. नेक्स्ट would be what? FS, shear. FS. So from R it is making an angle phi plus beta minus alpha. This whole angle is phi plus beta minus alpha. So FS can be written as R cos phi plus beta minus alpha. Clear? And we have seen in the earlier slide that Fs can also be written as tau s into p into t by sine phi. Clear? Next relation is what? Fn. Next relation is what? Fn. It can be written as Cfn. Fn is here. So this Fn, this is Fn. This is Fn. This is Fn. And this Fn is what angle it is making with R? Phi plus beta minus alpha. And this is the vertical component. So this will be R sine phi plus beta minus alpha. This is equal to sigma n p t by sine phi. Clear? So till now you have got the sixth relation. You have got the sixth relation, and these relations are very much important. These relations are very much important. Very much important. और इसको आपको याद नहीं करना है. याद नहीं करना है. See, Syam ji, please see this this reaction that is R in case of the orthogonal cutting. When we are fixing, this is R double dash, and at the earlier I have told you that the reaction on that chip, that is R, and the frictional force, that is reaction, that is R dash, both are equal, right? So at the earlier of the class I have told you, if you have again the problem, please again see that lecture. You will be and your confusion will be clear. Now see, ये जो है, this equation is very 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 important. Clear? Now let me tell you, from these thing, आपको जो है ना, एक चलिए मैं एक स्लाइड ले लेता हूँ. So till now these are the formula. This formula is very much important, and how we have got this formula. So I hope this is clear to you. Now from there a deduction is there. You can also derive these things, but not needed. So just I am giving you the formula. Please remember these formula as it is. As it is. First is F, F, N, Fs, and Fn. So there are four forces, F and N. So F and N is of due to friction, due to friction, and this Fs and Fn is due to shear, due to shear. Now what you need to write, how you can remember the formula, please see how I am writing. You can write Fc, 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 Fc. Here Ft, 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 Ft. This is a small trick through which you can remember the formulas. And what is the trick? In earlier class also, when I was giving you the example, when I have given the correlation between ASA to ORS interconversion, I have given you a trick to remember those formulas. So again I am using that Counter Strike. So how many of you have played Counter Strike? Counter Strike, how many of you have played? So in that Counter Strike, CS is there, right? So at that point also I have told you, so Counter Strike is there. So again start from Counter Strike, strike, counter. Clear? So how you can remember this? How you can remember this? So firstly you have to start from strike, counter, right? So see, strike, counter, strike, counter, then counter strike, then counter strike. Now here is their strike, you just write counter. There is counter, you just write strike, counter, strike, strike, counter. So in this way you will get a relation sine, cos, cos, sine, sine, cos. And what you have to remember, this is plus, this is minus, this is minus, and this is plus. Now please see, there is a thinking, there is a logic behind it. When you are calculating the shear, right? When you are calculating the shear, so you are dealing with the angle phi. When you are calculating the shear, you are dealing with the angle phi. So here the angle will be phi, 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 and clear. And when you are dealing with the friction, see, when the friction is there, when the friction is there, so it is acting on a rake surface, right? This is a rake surface, and in this rake surface the friction will act. So this angle is actually alpha. So there is a relation between alpha. So what you can write here is alpha, 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 and alpha. So this is the four relation that you please remember from the merchant circle analysis. These formula are important. Any doubt? Any doubt? Yes, Subham, I have told you the formula. Any doubt? I have told you the trick itself. If you have any doubt, then please tell me. Now, please tell me if you have any doubt till now. Do you have any doubt, or shall I proceed? So you have understood. What are the things you have understood? Sir, First thing is this: there are some formulas are there that I have deduced from the merchant circle, and this you have to remember. Okay, next is this. So for this I have told you this counter strike thing. If you can remember this counter strike thing, this trick is going to be very 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 handy for you, right? This trick is going to be very very handy for you. So यस शुभम, आप मेरे पहले लेक्चर्स को भी देख सकते हैं. यू कैन वॉच द ऑडियो लेक्चर्स ऑल्सो. आई हैव ऑलरेडी गिवन यू द ट्रिक because I do know the feelings of a student. They cannot remember everything, right? You cannot remember everything. Now see, now we are going to discuss some of the special cases. What are the special cases of the merchant circle? Please understand this very very cautiously. yahan se question pucha jata hai. From here questions are asked. See here. First case is if alpha is equal to 0. So alpha is equal to 0 means what? Here alpha is there, right? Here it is making some angle. Now see, if alpha is going to be 0, it will looks like something like this, right? See, this is the reference plane. This is the reference plane. And see, reference plane is there. So here what I can say? Alpha is equal to 0. Clear? Alpha is equal to 0. So when alpha is equal to 0, what is happening, sir? What is happening, sir? Let us see. This is your fs, this is your n, this is your fc, this is your ft, this is your frictional force F, and this is your, oh I'm sorry, this is your normal force due to shear. So this is your N. Clear? Now what will happen? See, let us say this A, B, C and D. So if alpha equal to 0, then first point, what is the first point? A, B, C, D. A, B, C, D is rectangle. A, B, C, D is rectangle, right? So this A, B, C, D, this whole thing will be rectangle. And what is the property of rectangle, sir? Property of rectangle is that, sir, opposite sides will be equal. So what does it mean, sir? This is FC. FC will be equal to N. See, this is your FC. FC is going to equal to N, and this is your FT. FT is going to be equal to F. Clear? So F is going to be, FT is going to be equal to F. So this is the thing that we have got. If alpha is equal to 0, then this thing we are getting, right? ये ऐसा कुछ हमको मिलता है. Next is this. Next point what we are getting is FC is perpendicular to F. See, this is FC and this is F. So FC is perpendicular to F. Clear? And F is perpendicular to V. And this F is perpendicular to V. So in this direction the cutting velocity is there, right? So somewhere like this cutting, okay, आपको दिख नहीं रहा होगा. So somewhere like this is the cutting velocity. So cutting velocity के साथ जो है हमारा frictional force F, this is perpendicular, right? So this means that alpha is equal to 0. So this is the deduction. This is the important deduction. Please remember this, sir. If alpha is equal to 0, first point is ABCD is going to be rectangle. Second is, sir, FC is N, FT is F, and FC is perpendicular to F, F is perpendicular to V. This is what is mean by alpha is equal to 0. Sir, till now this special case is clear to you or not? Sir, till now this special case is clear to you or not? Again I'm going to explain one more special case, but this special case is clear or not? Whenever, please understand, whenever in question, if it has been written that there is a orthogonal machining, and in that orthogonal machining alpha is equal to 0, alpha is equal to 0, so first thing that should come in our mind, that sir has told me that if alpha is equal to 0, then this is going to be equal. And you just have to think that okay, whatever the value of fc will be there, the same value of n will be there, whatever the value of ft will be there, the same value of f would be there. Clear? You are moving the tool, Indrajit. When you are machining, you are actually moving the tool, right? So break angle uska change ho gaya, right? Next case is if alpha is equal to 0, mu is equal to 1. Now please see what is the meaning of mu is equal to 1. Sir, if mu is equal to 1, then see here, I have not told you, I think. See here, from this equation, this is beta, and this is f, this is n. So can I write that tan beta is equal to f by n? Tan beta is equal to f by n, right? Tan beta is equal to f by n. So from this relation, what we can see here, if mu is equal to 1, right? So mu is equal to tan beta is equal to f by n. So just again writing, this is fs, this is fn, this is fc, this is ft, this is f, this is n, this is your shear plane, this angle is making alpha, right? This is your shear plane. Clear? This is your phi. So these things are there. Now when you are telling that alpha is equal to 0, so alpha will be 0, right? So here you can see the alpha is actually 0. So, and this angle is actually what? Beta. So beta, right? Tan beta is equal to mu. This is the coefficient of friction. Mu is coefficient of friction. This is coefficient of friction. Now see, the mu is equal to tan beta, that means f by n. So mu is given as 1, so 1 is equal to tan beta, so beta is actually getting as 45 degree. Beta is getting as 45 degree. Clear? So beta is getting as 45 degree. So for that case, if beta is equal to 45 degree, then again this A, B, C and D, this is what, sir? This is FC, this is FT, this is FS, this is FN, this is R, this is F, this is N. So if alpha is equal to 0, mu is equal to 1, that is beta is equal to 45 degree. So if 45 degree hoga, sir, the first thing kya hoga, sir? First thing will be ABCD will be square. ABCD will be square. This will be square, right? So if this will be square, then what are the things that we know? That F would be perpendicular to FC. So that just take this. So if it is ABCD is square, it simply means that F is equal to FC and FT is equal to N. Clear? Clear or not? F is equal to FC, right? So this is your F, FC, FT, and all are equal, sir. All are equal. FT and all are equal. Clear? Next thing what we can say here is this. Second point is, sir, F is perpendicular to FC. See, this is your F, this is FC. F is perpendicular to FC. Clear? Next is your F is perpendicular to VC. What is VC? Chip velocity. Clear? So this is the if alpha is equal to 0, mu is equal to 1, it means beta is equal to 45 degree. ABCD is going to be square. F is equal to FC is equal to FT is equal to N. And second point is F is perpendicular to FC and F is perpendicular to VC. So this is the second special case. This is the second special case. Till now clear? This is the second special case. And this was the first special case. This was the first special case. So these two special cases are clear to you. These two special cases are clear to you. Please tell me. These special cases are clear to you. Please tell me. Please tell me. Okay. Okay. So these things are very much important. Okay. Next, what are the limitations to use merchant force circle diagram, sir? Sir, merchant force circle diagram is valid only for orthogonal cutting. Sir, when merchant sir has made this, so he was been asked, merchant sir, can you draw this circle in terms of oblique cutting, sir? For oblique cutting, can you draw this circle? And merchant sir told, okay, I am failed. For oblique cutting, I cannot draw this because there are a lot of complications are there. So what is the alternative? What we can do? What we can do? We can convert the oblique angles, right? Whatever the angles or the things are there in case of oblique cutting to the orthogonal cutting. And once we are converting that oblique parameters to orthogonal parameter, then we can apply this MCD, right? So first limitations is MCD is valid only for orthogonal cutting. Next is by the ratio of F by N, the MCD gives apparent, not actual coefficient of friction, right? So we have seen that mu is equal to F by N. So this mu is not actual. Actual nahi hota, sir. This is approximate, right? This is approximate. Sir, why this is approximate, sir? Why this is approximate, sir? Because there is another assumption. It is based on single shear plane theory. See, sir, if you can see it very properly, when the chip is moving, now see, this is the chip. In this direction, the chip is moving. Now see, this is your shear plane. So this entire zone is primary shear zone. Primary shear zone. And in this primary shear zone, you cannot consider one shear plane, right? You cannot consider one shear plane. This is a zone, and in that zone there are multiple shear zones are there, multiple shear planes are there, right? So you cannot consider that in that zone only and only one shear plane is there. You cannot consider. So this is the assumption that they have taken. A single shear plane has been considered, and most important is there. So this is why the answers is approximate, right? Because there are a lot of shear planes are there. The theory is based on minimum energy principle. What is the minimum energy principle, sir? Suppose, since you have calculated, suppose there is a two shear plane. Suppose at this, consider I am taking the two shear plane. So for the first case, for the first plane, I am getting the, suppose power consumption is 150 watt, right? And from the another plane, there is 170 watt. Now, since this theory is based on minimum energy principle, so from merchant circle, you will get this answer. From merchant circle you will get this answer. But if you would change the shear plane, the answer would different. So there is a change in the power, there is a fluctuation in the power. So this is again the drawback. The theory is based on minimum energy principle, but it may not hold good, right? There can be another maximum principles would be there, maximum power can be there. So this is the thing. And the work behavior is ideal plastic. So these are the limitations of MCD. So I hope these things are clear to you. And if you have any doubt, then please ask me. So if you have any doubt, then please ask me. Otherwise, please solve this problem. Please solve this problem. If you have any doubt, then please ask me. Otherwise, try to solve this problem. So I'm giving you 2 to 3 minutes. Please try to give me the values of FC, radial force, normal force and FS. जिसका भी आप आंसर देंगे मुझे लिख दीजिएगा कि सर FS is equal to this Newton, N is equal to this, cutting force is this. Please try to solve it. I am giving you 2 to 3 minutes. Please try to solve it. And if you find the difficulty, then also comment me that sir, question is not good for me. I cannot comprehend the question. There is a problem with the question. I cannot understand it. Please also comment it. What are the problems you are facing? Please, those things, please tell me. Otherwise, just try to solve this problem. I'm giving you 2 minutes. Please tell me the answer. Okay, see, just मैं आपको क्वेश्चन एक बार समझा देता हूँ. See, in this question, the following data for the orthogonal cutting test is available. Rake angle. Rake angle is given as 10. So, given things. What are the given things? So, given thing is rake angle. Rake angle is 10. 10 degree given. Okay. Now, chip thickness ratio is 0.35. So, chip thickness ratio R is given as 0.35. Uncut chip thickness. What is the uncut chip thickness? Uncut chip thickness, that is T, that is 0.51 mm. Clear? Next is what? Width of cut is 3 mm. What is the width of cut? That is B. B is your width of cut. This is given as 3 mm. Yield shear stress of the work material is 285. So what is yield shear stress? That is tau, right? Tau y. Tau yielding is given as 285 Newton per millimeter square. Mean friction coefficient on the tool face is given as 0.65. That is mu is given as 0.65. So these datas are given to you. What you need to find: FC, radial force, normal force, shear force. Please tell me the answer. Now please tell me the answer. I am waiting for your queries, and if you don't have any queries, then please tell me the answer. Okay, so there is a delay. See, whatever the concept I have told you, these concepts are enough to solve this problem. So please try to give me the answer, right? Please try to give me the answer. Anybody? Nobody is. सबको दिक्कत है. Okay, I'm giving you more 20 to 30 seconds because this question is also lengthy. Indrajit has told FC is equal to 1.265 kilonewton. Okay. Indrajit, could you check your answer? Whatever the answer you have told, is this the answer of FC or FS? Please check. Please check. Yes, Mukta, I am waiting. I just want you guys to try. Take 1 more minute. Give me the values. Indrajit, please check your answer. Syam, Shivam, please participate. Please tell me the answer, whatever you are getting. Ajay, please tell me the answer. Yes, Indrajit, that is the value of Fs. Okay, try to solve the value of n. See what you can do. What you can do here, see from this slide, this you can use this all this ये सारा formula आप use कर सकते हैं, है ना? Just try to use this all things and your problem will be solved, right? This is your problem. Please try to solve. Tell me the answer, Indrajit. See, first thing that you have to do is you have to find phi. So how you can find phi? Tan phi is equal to r cos alpha by 1 minus r sin alpha. So from here you will get the phi is equal to tan inverse of r. R is given as 0.35 cos of 10 by 1 minus of 0.35 sine of 10. So from here you will get the value of phi as 20.152 degree. Okay, 20.152 degree. Now what you can do, you can use this formula. Fs is equal to tau into b by e bt by sine. Okay, so from here so from here so from here Fs would be is equal to tau is given as 285 Newton per millimeter square. This b is given as 3 mm, 3 mm. T is given as 0.51, 0.51 sine phi, sine of 20.152. So from here you can find the value of shear force, and the shear force value is 1265.7 Newton. Clear? 1265.7 Newton. So first step is this. First find phi, then find Fs. Clear? Then find Fs. Then the value of Fs is this. Then the value of Fs is this. No one is giving me the answer. I have checked again. Okay, no problem. So from after that is what? Third thing is this. Third thing is this. Third thing is that we know that mu is equal to tan beta, and mu is given as that mu is given as 0.65. See here, this question is given as mu is 0.65. So 0.65 is given. So can I write that beta will be is equal to tan inverse of 0.65, which is going to be equal to 33.023 degree. So this is the value of beta, right? This is the value of beta. And if you will draw the merchant circle, just I'm drawing the merchant circle. So this is the merchant circle. This is your R. This is your FC. This is your FT. This is your this is your FT. This is your FC. This is FS. This is FN. This is N. This is F. This is N. This is making angle beta. This is beta minus alpha. This is beta minus alpha, and this angle is alpha. This angle is phi. So this is the merchant circle diagram. So from this merchant circle diagram, what we can see that Fs, see here, Fs is equal to R cos of phi plus beta minus alpha. See, beta minus alpha, this is beta minus alpha, this is beta minus alpha. So beta minus alpha plus phi. So from here you can find the value of R. R would be Fs by cos of phi plus beta minus alpha. All the values are given to you. From here you can find the value of R, and R would get as 1735.6 Newton. So this is the value of Fs you are getting. This is the value of Fs you are getting. Clear? So this is the value of R you are getting. Now once you have got the value of R, so next thing is what? Next thing is cutting force. So how you can find the cutting force? Fc is equal to R cos of beta minus alpha. So R is what? R is 1735.6 cos of beta. Beta is given as 33.023 minus alpha. Alpha is given as, in this question, alpha is given as 10. So from here you will get the value of FC. FC would be 1597.3 Newton. So this is the value of FC you got. Clear? And in earlier you have found out the value of Fs. Okay, Fs का value आपको पता ही है. Next is what? Next is N, normal force on tool. Normal force on tool, that is N. How you can find the value of N? N is equal to R cos beta. See here, N is equal to R cos beta. This is R cos beta. So from here, N R would be 1735.6 cos of beta, cos of 33.023. So from here, N will come around 1455.2 Newton. So this is the normal force on tool. So you have found out the normal force on tool, you have found out the cutting force, and you have found out the shear force. So everything is. Now there is a problem. What is this radial force? What is this radial force? Sir, in question it has been given orthogonal cutting. So orthogonal cutting में sir क्या होता है? Only FC and FT is there. That is, two forces are there. So radial force will come in case of oblique cutting. In orthogonal machining, radial force will not come. So the radial force value will be 0. Okay, so this will be, radial force will be 0. Clear till now? It is clear or not? This problem is clear or not? Tell me. Okay, let me check the comments. Mukta has told beta is equal to 33.023. Yes, you are right. Next, Indrajit has told R is equal to 1.884. No, Indrajit. Okay, yes, 1.734. Yes, it is right. Next, Mukta has told 1.596. Okay. So I hope these things are clear to you. So if these things are clear to you, then please try to solve this another question. GATE 2010. Please try to solve this another question. GATE 2010. It has came in the production engineering. Why I am doing this question? Okay, don't do this question. Don't do this question. Just do this question. Just do this question. In the next class, I will explain you these things. Okay, but try to solve this question. GATE 2013 problem is there. Please tell me the answer. This is the previous year GATE 2013 mechanical question is there. Please tell me the answer. Great. I'm happy that whatever I'm explaining to you, you are getting whatever I want to give to you. Okay, so no doubt is there, then I'm very much happiest person. I'm very happy. Please try to solve this question. Okay, 2013 problem is there. Please try to solve this problem. I'm giving you 2 minutes. Okay, and after 2 minutes I will explain you. I'm giving you 2 minutes, and after 2 minutes I'm going to explain you. प्लीज पार्टिसिपेट, प्लीज पार्टिसिपेट। जितने लोग भी हैं ना, प्लीज आंसर दें मुझे। आप गलत आंसर देंगे मुझे कुछ नहीं, कोई फर्क नहीं पड़ेगा, बट आई विल अप्रिसिएट योर पार्टिसिपेशन, ओके, बिकॉज अल्टीमेटली आई एम एक्सप्लेनिंग यू, so that doesn't means a lot. Please participate, please tell me the answer, whatever you think, please tell me the answer. Please tell me the answer. Okay, so I have got the answer as Kiran has told me 0, Indrajit has told me 0, Mukta has told me 0, Shivam has told me 0. Okay, great. See, see, there is nothing in this question, right? In this question, the examiner has tried to manipulate you everything in each and every way. Orthogonal turning he has given the diameter d is equal to what, 100 mm. Feed is given, depth of cut is given, cutting velocity is given. It is observed that main tangential cutting force is perpendicular to friction force. So what is your important thing? This is main cutting, that is tangential cutting force is perpendicular to friction force, right? So this is a orthogonal turning. In orthogonal turning, please see here, see, for orthogonal turning, what are the things that is given? This is a orthogonal turning, orthogonal turning. And in this orthogonal turning, tangential, that is cutting force, is perpendicular to the friction force, that is Fc is perpendicular to F. Fc is perpendicular to F. Now see here, now see here, Fc is perpendicular to F. Fc is perpendicular to F, then alpha is equal to 0. This is why I was telling you this is the two special case from the merchant circle. If you can remember, if you can understand, if you can feel these things, you just do not have to even touch the pen, and your answer will be okay. So if those things are in your mind, then you can say, sir, since Fc is perpendicular to F and this is a special case in which alpha is equal to 0, so alpha is equal to 0. So even without touching the pen, you can solve this problem very easily. Clear? Next question. Please solve this. Please solve this. Again, I am giving you 2 to 3 minutes. Please try to solve this question. Please tell me the answer. Normal force. In this question, same data is there. Normal force is being asked. What is the value of normal force? Okay. What would be the value of normal force? So Shivam has told 1500. Anybody else? Anybody else? Please tell me. 1 minute more. Please tell me. Please tell me. FC equal to N. Okay. C. C. See, in this problem, what is being told that alpha is going to be 0. Alpha is 0, right? So when alpha is 0 and FC is perpendicular to F, right, then we know that the condition is there that F and let me draw the merchant circle diagram. This is a merchant circle diagram. This is a R. This is FC. This is FT. This is FS. This is FN. This is FF, F, and this is N. So for this case, this would be there. This would be a rectangle. This will be a rectangle. Fine. So this will be a rectangle. In this rectangle, this FC will be is equal to N and F is equal to FT. And what is being asked that, see, main cutting force is given as 1500, right? So main cutting force is given as 1500. So FC is given as 1500 Newton. So from this figure, FC will be is equal to N. So FC is equal to N, which is equal to 1500 Newton. So 1500 Newton is your correct answer. Clear? So I hope there is no doubt. So this is the way to solve the GATE problems. I hope you are enjoying my lectures. You are enjoying the way I am teaching to you, because believe me, I am working more harder than what you are actually doing to bring the good content and the good material and the good way to give you the concepts. So I hope you are enjoying that, and if, then please try to solve this problem. Another problem is there, GATE 2015 problem is there. Please try to solve it. Please tell me the answer. Yes, Subham, please solve the questions. Thank you. Please solve the questions. I will be very much happy if you would score a great marks, and in the GATE you may be a topper. Then I would be super happy with that, right? So please try to solve this question. Please tell me the answer. See, मैं आपको क्वेश्चन समझा देता हूँ. Single point cutting tool is there, 0 degree rake angle is there. Sir, what is given? Sir, alpha is given 0 degree. Fine. Number 1, used in orthogonal machining. Sir, machining क्या है sir? Orthogonal. चलिए आगे बढ़ते हैं. Cutting speed is given as 180 per meter per minute. So cutting speed is given as 180 meter per minute. Next, thrust force. Thrust force क्या है sir? Thrust force given as 490 Newton. See, this is the thrust force that has been given. Coefficient of friction between tool and chip is given as 0.7. So coefficient of friction is given as 0.7. Power consumption. Sir, आपसे क्या पूछ रहा है sir? Power पूछ रहा है sir. Power कितना लगेगा sir? Please tell me sir. Please tell me, sir, what would be the power consumption? What would be the power consumption? सर गेट में जो क्वेश्चंस है ना बहुत आसान पूछे जाते हैं। और चलिए शिवम जी का आंसर भी आ गया, और शिवम जी के लिए एक तालियां, बिकॉज ही हैज गिवन द करेक्ट आंसर, और सबसे पहले वो आंसर दिए हैं। सो वेरी गुड शिवम जी, आप आंसर ऐसे ही देते रहें। प्लीज ट्राई टू गिव द आंसर्स सेम वे, एंड अ डे विल कम व्हेन यू विल बी गेटिंग अ गुड स्कोर, राइट? ग्रेट, इंद्रजीत जी का भी आंसर आ गया 2.1 किलोवाट। So again a clapping for Indrajit ji also. Please whatever आप लोग और क्या कर रहे हैं, 2.1 किलोवाट तो दो लोगों का आ गया आंसर, बाकी लोगों का क्या हाल चाल है? बाकी लोगों का क्या हाल चाल है? बन नहीं रहा या समझ में नहीं आ रहा? अरे सर देखिए, कुछ है ही नहीं सर, क्या बोल रहे हैं सर? म्यू जो है 0.7 है सर। अच्छा, मर्चेंट सर्कल अगर आपके दिमाग में रहेगा, तड़ से आप मर्चेंट सर्कल बना लीजिए। सबसे पहले क्या सर, दिस इज योर आर, दिस इज योर एफ सी, दिस इज योर एफ सी, दिस इज योर एफ टी, राइट? दिस इज योर एफ एस, दिस इज योर एफ एन, दिस इज योर एफ, and this is your N. So this is the merchant circle. Very fast, just draw the merchant circle. Okay, Mukta ji, you have also given the correct answer. So this is the merchant circle. From here, we know that mu is given as 0.7. So mu is given as 0.7. That is, this is the beta. This is the friction angle. So mu is given as 0.7. That is F by N. Clear? F by N. Now, since this is a 0-degree rake angle, right? So alpha is equal to 0. Since this is a 0-degree rake angle, alpha is going to be 0, and see this is going to be a rectangle. Clear? In this rectangle, what would happen, sir? FC would be equal to N, FT would be equal to F. Clear, sir? Clear, sir? So if that is the case, then mu is equal to F by N is equal to FT by FC. FT by FC. F के बदले सर मैं क्या लिख सकता हूँ? FT. और N के बदले क्या लिख सकता हूँ सर? FC. So this is the way. In place of F, I have written FT, N, I have written FC. And here FC, here FT is given as 490. So what you can do here, mu is given as 0.7. So from here we will get the value of FC is equal to 700 Newton. So from this relation, you will get the value of FC, and the value of FC is 700 Newton. And see, power is what? Power is cutting power, right? Maximum power जहां आपका लगता है सर, maximum power consumption is due to the cutting, right? When we are cutting, that is the actually उसके कारण जो है हमारा मैक्सिमम पावर होता है सर। तो पावर इज नथिंग बट कटिंग फोर्स इनटू वेलोसिटी. दिस इज योर कटिंग फोर्स, this is your cutting velocity, and power is going to be 700 Newton into cutting velocity. Sir, cutting velocity is 180 meter per minute. So meter per second mein if I would convert it, then it would be in 60, and the P is going to be your 2.1 kilowatt. This is your answer. Clear? Clear? If that is clear, please solve this question. Please solve this question. IAS 1999. Now to solve this problem, I must say one more thing. There is the merchant formula. Merchant formula. What is this merchant formula? Sir, merchant sir has told that, dear students, if you have the beta relation, if you have the alpha, if you have the phi, then I'm giving you one relation between them. And what is the relation, sir? That relation is phi is equal to pi by 4 plus alpha by 2 minus beta by 2. This can also be written as 2 phi plus beta is equal to 90, that is pi by 2 plus alpha. So in either way you can remember these things, both are same, right? So this is the merchant formula, and please use this merchant formula to tell me the answer. Good, Syam, good Syamji, you are solving good in good way. Please follow my lecture so that your all the concepts will get clear. Please tell me the answer. Please tell me the answer. Indrajit 47.75. Please check your answer, Indrajit. Please check your answer once again. Please check your answer. Please check your answer, Indrajit. Rake angle is given as 20. Friction angle is given as 25.5. Okay. See, rake angle is given as a 20 degree. Friction angle is given as a 25.5. Okay. So how you can use these two angles and calculate the value of phi, that is shear angle. Please check your answer in the G. Please tell me the answer. Very easy problem is there. You are not telling me the answer. I am waiting for your answer. Just you have to take the calculator and calculate it, and even if that you are not doing. This is not a good way. Please reply me. At least give me the answer. I have told you everything. Now I want your answer. Now Indrajit has told me the answer as B. Okay. Anybody else? So Indrajit has told me the correct answer. सबसे पहले इंद्रजीत जी ने बताया मुझे. So good clapping for Indrajit. Kiran C. Okay. How Kiran? How it should be C? Let me use the calculator. Shyam. Shyam ji का क्या आंसर आया? 42.25. Yes, Shyam, it is correct. See, I have also calculated. Nothing you have to do. Just you take this formula. Phi is equal to 45 degree plus of alpha by 2, that is 20 by 2, minus of beta by 2, that is 25.5 by 2, and if you would calculate it, you will get the value of phi as 42 point. Kiran never tells the wrong answer, but today Kiran has told me the wrong answer. Why, Kiran? Why is it so? Okay, so this is every questions have explained everything I have covered till now. Till now, if you have any doubt, any type of doubt, then please let me know. Please tell me any doubt. If you have any doubt, please ask with me. Otherwise, I am going to end this session. This is what is from my side for today. And one more thing is there, one more announcement that I want to make is in Unacademy learning app. In Unacademy learning app, from tomorrow, I am going to take the class at 11 a.m. of strength of material at Unacademy learning app. You can search Vidyapati Kumar. You can search about me or at the rate of v.ksir. And tomorrow I'm going to take the class of strength of material, so whosoever is interested, they can join my class tomorrow 11 a.m. for strength of material. And if you have any doubt, please ask with me. 2 minutes I'm giving you. If you have any doubts, ask with me, otherwise I'm going to end the session. Next class timing, Syam ji, I take the classes of manufacturing. I take the classes of manufacturing at 8:45 a.m. daily. Regularly, I am taking the manufacturing class 8:45 a.m. So you can ask me, no problem, Syam. I know this is your first lecture. You can watch my previous 5 lectures I have given. You can watch it, and you can understand the concept from there. No worries is there. But I take daily classes. I take of manufacturing engineering at 8:45 p.m. I'm so sorry. I'm so sorry. So this is my timing. So I assume that you guys don't have any doubt. Uh, yes, Kiran. Yes, Kiran. I have changed it. Any doubt? Thank you, Kiran. Any doubt? So I assume that you don't have any doubt. And please do like this video if you really enjoyed my lectures. And if anybody is interested to purchase the plus subscription, please use this code SIRVK. You will get the additional 10% discount while purchasing, as well as I will provide my personal mentorship to you. और मैं आपका कभी हाथ नहीं छोड़ूंगा till GATE 2021. रैंक लाना है बहुत अच्छा GATE 2021 में. टारगेट फॉर AIR1. टारगेट फॉर AIR1, नॉट लेस देन 1, नॉट लेस देन 1. सर 2 डिजिट 3 डिजिट नहीं, 1 के लिए पढ़ाई कीजिए, तब जाकर कुछ होगा, एल्स कुछ भी नहीं होगा. So this is from my side. Thank you so much. I'm really happy for your active participations, and your gracious presence is really appreciated from my side. Thank you so much, and signing off from my side. Thank you.